This video goes over examples of relations. So a relation is just a relationship between two variables. Most of what we'll be doing will be using x and y to represent those two variables. We could represent a relation as a set of ordered pairs, as you see here. We can represent them as a graph. So 4 minus 3 minus 2, 0, 0, 3, 2, 6, 4, 9. Okay. We can also represent a relation as a table of values. So I'm going to put those points in here, 0, 3, 2, 6, and 4, 9. Now, a couple of things that we need to be familiar with is the independent variable is x. It's graphed on the horizontal axis and written in the left column of a table of values. The dependent variable is y. It's graphed on the vertical axis and is written in the right column of a table of values. F is a linear relation because the graph looks like a line, and because the difference is constant in the table of values. And let's take a minute to look at what I mean by that. I mean that the x values are all going up by 2, and the y values are all going up by 3. So they are each going up by the same value each time. X is going up by 2, y is going up by 3. 2 more points that follow the pattern would be 6, 12, and 8, 15. If x increased by 2 and y increased by 2, so if we got the point, let's say 10, 17, that point would not follow the pattern because y is increasing by 3. We want to be able to tell if a relation is linear without having to graph it all the time. In order to do that, we can create the difference table for each table of values. And from that, we can decide if the data represents a linear or nonlinear relationship. So if we can graph each relationship to check here. So when we're looking for the difference table, we are looking for what x goes up by. So in this case, it's going up by 1 each time. And we say that our change in x is equal to 1. Now we're going to do the same thing for our y values. So if I check my first 2, I'm going up by 3. Then I'm going up by 5. Then I'm going up by 7. And then I'm going up by 9. It is a pattern, but it's not the same number. So that means that our first differences are not constant, not the same number. So this is a non-linear relationship. So let's put them on a graph to check. So we've got 1, 1, 2, 3, 4, 3, 5, 6, 7, 8, 9, 4, 16, 11, 12, 13, 14, 15, 16, and then my last one won't fit on there, which is fine. But what I can see is that these points are going to follow a curve here, so which is non-linear. Let's do one more example. So the first thing I'm going to notice is that my x values are not in order. Before I check the differences between them, I do need to put them in order. So I'm going to look for the smallest value of x, which is 2. So that is still my first one. My next smallest x value is 4, then 6, then 8, then 10. Now I can check my differences between the x. So I'm going up by 2, up by 2, and up by 2. So my change in x is 2. And I'm going to look at my y's. Between my first two, I'm going down by 4. My second two, I'm going down by 4. Third two, going down by 4. And my last ones, I'm going down by 4. So that means that my change in y is -4. And I can say, since my first differences are constant, this is going to be a linear relationship. Let's put them on the graph just to make sure. 2, I think that's 10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then we've got 4, 7, 6. Then we've got 6, 2. Then we've got 8 minus 2. And then we've got 10 minus 6. So 2, 3, 4, 5, 6. Those points are going to follow a line. So I do have a linear relationship, which I can see if I use a ruler. And I put it up to those points. Those are all going to go right through my points. There, they look like a line. Okay. That is an example of how to use a difference table to decide whether a relation is linear or nonlinear.